All right, let's just get right into it. The universe is ancient, it's mind-bogglingly huge, and yet it is completely silent. I mean, we've been listening for decades now, and all we've found is nothing. It's one of the biggest, most profound mysteries out there. So today, we're going to dig into the prime suspect in this cosmic detective story, a really chilling calculation that might just explain why the universe is so quiet.
And it all starts with this one simple question, famously asked by the physicist Enrico Fermi way back in 1950. He was just looking at the sheer odds of it all, and he realized, something just doesn't add up. And this question, which we now call the Fermi Paradox, is the puzzle we're trying to solve today. So before we get to the possible answers, let's just take a second to set the stage here, to really appreciate the scale of this problem. Because when you look at the numbers, the silence gets even louder.
I mean, just think about the sheer number of opportunities. Our galaxy, the Milky Way, has at least 200 billion stars. And we now know that most of those stars have planets. Billions of them are probably Earth-like, orbiting in what we call the habitable zone, where water could exist as a liquid. Billions!
So here's the thing, with billions and billions of chances playing out over billions of years, it feels almost inevitable that intelligent technological life should have popped up many, many times. Some of these civilizations would likely be millions, maybe even a billion years older than us. That's a tiny head start in cosmic time.
And if even just one of those civilizations decided to expand, they could have colonized the entire galaxy in just a few million years, which is like a blink of an eye on a cosmic scale. We should be seeing something, probes, giant structures, or at the very least, hearing their signals. But we don't. So where is everybody? To even begin to tackle that, scientists came up with a framework.
And this brings us to the main tool scientists use to get their heads around this paradox. Now, it's not a magic bullet, but it is the best blueprint we've got for this whole cosmic mystery.
This is it, the famous Drake equation. An astronomer named Frank Drake came up with it back in 1961, not to get a perfect exact answer, but, as he put it, to organize our ignorance. It basically breaks down the massive question, are we alone, into a series of smaller, slightly more manageable pieces. You can think of it like a cosmic recipe, right? You start with the rate of star formation, multiply that by the fraction of stars that have planets, then the number of those that are habitable, and you just keep going down the line. Now, thanks to modern astronomy, we're actually getting pretty good guesses for the first few ingredients. But those last few, like how long a civilization survives, that's where we're basically flying blind.
And here's the real kicker. Depending on how optimistic or pessimistic you are about those last few variables, the final number of civilizations we could detect, N, can swing wildly. We're talking from millions of them out there right now, all the way down to just one, us. The entire paradox really just hangs on what those last few numbers turn out to be.
And this leads us to a truly chilling possibility. We're going to zoom in on that very last variable in the equation, L, which stands for the lifespan of a civilization. You see, some scientists think the universe is quiet for one simple reason. L is terrifyingly short. This quote from a paper by John Sotos really gets to the heart of a concept called the Great Filter. The idea is that there's some kind of barrier that's just incredibly difficult for life to get past. And the terrifying part is, what if that filter isn't in our past? What if it's in our future? And what if it's a technology we are racing to develop right this second? So the crucial point here is that maybe, just maybe, the reason we don't hear from anyone is that as soon as a civilization gets technologically advanced enough to send signals, it also gets advanced enough to destroy itself. And it doesn't take very long for that to happen. A researcher named John Sotos built this simple but, wow, incredibly powerful model for this idea. He boiled the whole risk down to just two things. E is the number of entities, could be people, groups, even AIs, who have the power to basically end civilization. And P is the yearly chance that any one of them will actually use that power, whether it's on purpose, by accident, or out of just plain madness. And the result of this model is sobering, to say the least. If a technology that could end civilization, like advanced biotech, becomes widespread, let's say 1 million people can get their hands on it, the median survival time for that civilization absolutely plummets.
Even if you're super optimistic about human nature, the model still predicts a lifespan of only a few hundred years.
So, if this pattern holds true all across the cosmos, that intelligence always creates technology that leads to a quick self-destruction, then that right there would be the great filter. It would explain the silence perfectly. The galaxy could have been teeming with civilizations, but maybe each one only lasted for a cosmic minute before just blinking out. Okay, so that was pretty grim. But what if they are out there? What if the great filter isn't the right answer? Let's explore some of the more speculative, but honestly just as fascinating theories for the silence. These are two of the biggest ideas out there, and they're polar opposites. On one hand, you've got the zoo hypothesis. It's a pretty harmless idea that we're basically in a protected nature preserve and they're leaving us alone to develop naturally. But on the other hand, you have the truly terrifying dark forest hypothesis, which says the universe is a dangerous place and the smartest thing to do is stay quiet and get rid of any other life you find before it finds you. And there's this really powerful analogy for this whole idea. Maybe they know we're here, but we are so cosmically insignificant that we just don't even register. To some galactic civilization, we might simply be ants, you know? They're not hostile, they're not friendly, they just have no reason to care about us at all. Of course, there are also less dramatic possibilities. Maybe our radio technology is just hopelessly primitive, and they're all communicating with, I don't know, quantum entanglement or something we can't even dream of yet. Or maybe space and time are just too vast. Or, hey, perhaps we're just the first ones to the party. Someone has to be, right? So let's just bring it all together. The answer to Fermi's big question, where is everybody, probably falls into one of these four camps. Either the universe is empty, and we're it, or it's a graveyard of civilizations that didn't make it, or it's a crowded place, but everyone is either hiding from each other, or they're just politely ignoring the new kids in the cosmic zoo. Ultimately, we just don't know the answer, but all these possibilities force us to look in the mirror. That empty sky might not be a reflection of the cosmos, but a reflection of the inevitable fate of intelligent life. So, is the great silence a puzzle for us to solve, or is it a warning about the path we're on right now? The search continues.